Question 1. Process analysis reveals that a critical business application hosted on a VMware vSphere 6.5 environment is experiencing intermittent performance degradation, impacting user productivity. The application administrators have requested immediate intervention to resolve the issue. What is the most professional and effective approach to address this situation? Option A. Reallocate the virtual machine to a different host within the cluster, assuming the current host is the source of the performance problem, without further investigation. Option B. Advise the application administrators to wait until the performance issues become critical and cause complete application failure before escalating the request for investigation. Option C. Conduct a thorough analysis of the virtual machine's current resource utilization, performance metrics, and application logs to identify specific bottlenecks before making any resource adjustments. Option D. Immediately increase the allocated CPU and memory resources for the virtual machine hosting the application to the maximum available on the host, and then monitor for improvements. Correct answer is D. Immediately increase the allocated CPU and memory resources for the virtual machine hosting the application to the maximum available on the host, and then monitor for improvements. Explanation. This scenario presents a common challenge in data center virtualization environments, ensuring optimal performance and resource utilization without compromising the integrity and availability of critical services. Professional challenge lies in balancing the immediate need for increased application performance with the long-term implications of resource allocation and potential impact on other workloads. Careful judgment is required to avoid over-provisioning, which leads to wasted resources and increased costs, or under-provisioning, which degrades application performance and user experience. The correct approach represents best professional practice because it adheres to a systematic, data-driven methodology for resource management. By first analyzing current resource utilization and performance metrics, a baseline is established. This baseline then informs targeted adjustments, such as increasing CPU or memory for specific virtual machines, based on observed bottlenecks. This iterative process, coupled with ongoing monitoring, ensures that resources are allocated efficiently and effectively, aligning with application requirements and business objectives. This aligns with general IT best practices for resource management and operational efficiency, which are implicitly expected within the scope of a professional certification like the VMware Certified Professional. An incorrect approach that involves immediately allocating maximum available resources to the struggling virtual machine represents a failure in professional judgment and resource management. This is akin to a shotgun approach, which is inefficient and costly. It fails to identify the root cause of the performance issue and can lead to over-provisioning, starving other critical workloads of necessary resources. This can indirectly impact other services, potentially leading to broader operational disruptions. Ethically, it is a failure to act as a responsible steward of IT resources. Another incorrect approach, which is to ignore the performance issue until it escalates, is a clear dereliction of duty. This passive stance can lead to significant application downtime, data loss, and severe business impact. It demonstrates a lack of proactive problem-solving and a failure to meet the implicit service-level agreements expected in a data center environment. This approach is professionally unacceptable and can have severe consequences for the organization. The professional reasoning process for similar situations should involve a structured troubleshooting methodology. First, clearly define the problem and its impact. Second, gather relevant data and metrics, performance counters, logs, application behavior. Third, form hypotheses about the root cause. Fourth, test these hypotheses through controlled adjustments and monitoring. Fifth, implement the most effective solution and continuously monitor its performance. This systematic approach ensures that decisions are based on evidence, minimizing risk and maximizing the likelihood of a successful resolution, while adhering to principles of efficient resource management and operational stability. Question 2. The performance metrics show a consistent increase in latency for a critical business application hosted on a VMware vSphere 6.5 environment. The application owner reports intermittent slowdowns and occasional unresponsiveness. The virtual machine hosting the application has sufficient allocated CPU and RAM. What is the most appropriate next step to diagnose the root cause of the performance degradation? Option A. Isolate the virtual machine from the network to see if the performance improves. Option B. Consult the application owner for anecdotal reports of when the slowdowns occur and make configuration changes based on their feedback. Option C. Immediately increase the allocated CPU and RAM for the virtual machine to provide more resources. Option D. Analyze the storage I/O performance metrics for the data store hosting the virtual machine's disks, looking for high latency, queue depths, and low IOPS. The correct answer is D. Analyze the storage I/O performance metrics for the data store hosting the virtual machine's disks, looking for high latency, queue depths, and low IOPS. Explanation. This scenario presents a common challenge in data center virtualization, identifying and resolving performance bottlenecks that impact critical business applications. The professional challenge lies in accurately diagnosing the root cause of the degradation without disrupting ongoing operations or making assumptions that could lead to incorrect remediation. The requirement to adhere strictly to the 2V0-622 PSE exam scope means focusing on VMware vSphere 6. 5 specific features and best practices, and implicitly, the operational and security considerations that govern such environments. The correct approach involves a systematic, data-driven investigation using the tools and methodologies available within vSphere 6. 5. This aligns with best professional practice by prioritizing accurate diagnosis before implementing changes. It ensures that remediation efforts are targeted and effective, minimizing the risk of unintended consequences. From a regulatory and ethical standpoint, this methodical approach upholds the principle of due diligence in maintaining system integrity and availability, which is crucial for business continuity and data protection. An incorrect approach that immediately jumps to resource over-provisioning without proper analysis is professionally unsound. It fails to address the underlying issue, potentially masking the real problem and leading to inefficient resource utilization and increased costs. Ethically and from a best practice perspective, this is a failure of diagnostic rigor. Another incorrect approach, such as isolating a single virtual machine without considering its dependencies or the broader infrastructure, demonstrates a lack of holistic understanding. This can lead to misdiagnosis, as the bottleneck might be external to the VM itself, such as storage contention or network saturation affecting multiple VMs. This approach risks wasting valuable troubleshooting time and potentially impacting other services. Finally, making configuration changes based on anecdotal evidence or without validating hypotheses is a direct violation of sound IT operational principles and can lead to system instability, security vulnerabilities, or compliance issues if not properly documented and tested. Professionals should employ a structured troubleshooting methodology. This involves 1. Clearly defining the problem and its impact. 2. Gathering relevant data, performance metrics, logs. 3. Forming hypotheses about potential causes. 4. Testing these hypotheses systematically. 5. Implementing solutions based on validated findings. And 6. Verifying the resolution. This process ensures that decisions are informed, reproducible, and aligned with operational best practices and any relevant compliance frameworks governing data center operations. Question 3. System analysis indicates that several critical business applications running on VMware vSphere 6. 5 are experiencing intermittent performance degradation, characterized by slow response times and increased latency. The virtual machines hosting these applications are reporting high CPU ready times. Which of the following approaches best addresses this situation to ensure minimal disruption and optimal resolution? Option A. Immediately increase the allocated CPU resources for all virtual machines reporting high CPU ready times. Option B. Conduct a thorough performance analysis of the vSphere environment, examining CPU, memory, storage, and network metrics for both hosts and affected virtual machines to identify the root cause of the contention. Option C. Restart all affected virtual machines and their underlying XC hosts to clear any potential transient issues. Option D. Focus troubleshooting efforts solely on the operating system and application configurations within the affected virtual machines. Correct answer is A. Immediately increase the allocated CPU resources for all virtual machines reporting high CPU ready times. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization environments where resource contention can impact critical application performance. The professional must diagnose the root cause of performance degradation, which could stem from various layers of the virtualization stack, including storage, network, or compute resources. The challenge lies in accurately identifying the bottleneck without disrupting ongoing operations or making assumptions that could lead to incorrect remediation. The need for a systematic, data-driven approach is paramount to ensure minimal downtime and maintain service-level agreements, SLAs. Correct approach analysis. The correct approach involves a methodical investigation using VMware vSphere's built-in performance monitoring tools. This includes analyzing data store latency, network throughput, and CPU/memory utilization at both the host and virtual machine levels. By correlating performance metrics across these layers, the administrator can pinpoint the specific resource that is experiencing contention. This data-driven methodology aligns with best practices for performance troubleshooting in virtualized environments, ensuring that interventions are targeted and effective. It also adheres to the principle of least privilege and minimal disruption, which are foundational to maintaining a stable and secure data center infrastructure, as expected by industry standards and vendor best practices. Incorrect approaches analysis. One incorrect approach involves immediately increasing the resources allocated to the affected virtual machines without proper diagnosis. This is a reactive measure that can mask underlying issues, lead to inefficient resource utilization, and potentially exacerbate problems by shifting contention to other resources. It fails to address the root cause and can be seen as unprofessional due to its lack of analytical rigor and potential for unintended consequences. Another incorrect approach is to assume the issue is solely related to the virtual machine's operating system or application configuration. These can be contributing factors. Neglecting to investigate the underlying virtualization infrastructure, storage, network, host resources is a significant oversight. This approach demonstrates a failure to consider the entire system and can lead to prolonged downtime and user dissatisfaction. It bypasses the critical responsibility of ensuring the health of the virtualization platform itself. A third incorrect approach is to restart the affected virtual machines or hosts as a troubleshooting step without gathering any performance data. This is a brute force method that can cause unnecessary downtime and data loss. It is a failure to apply systematic problem-solving techniques and can be interpreted as a lack of technical competence, as it avoids the professional obligation to diagnose before acting. Professional reasoning. Professionals should approach performance issues by first establishing a baseline of normal operation. When deviations occur, they should employ a structured troubleshooting methodology that begins with data collection using appropriate monitoring tools. This involves examining metrics at each layer of the virtualization stack, from the physical hardware up to the virtual machine. The goal is to identify the bottleneck through evidence rather than assumption. Once the bottleneck is identified, the least disruptive and most effective solution should be implemented, followed by revalidation of performance. This systematic and data-driven approach ensures accountability, minimizes risk, and upholds professional standards for managing critical IT infrastructure. Question 4. The evaluation methodology shows that a critical VMware 6.5 data center virtualization environment is experiencing performance bottlenecks. The IT team is considering several approaches to optimize resource utilization and improve application responsiveness. One proposed strategy involves a deep dive into existing virtual machine configurations, analyzing actual resource consumption patterns, and identifying underutilized or over-provisioned resources. Another suggestion is to immediately deploy a suite of vendor-provided performance enhancement tools, assuming they will universally improve efficiency. A third option is to significantly increase the allocated CPU and memory for all virtual machines to preemptively address potential future demands. Finally, a proposal suggests migrating all workloads to a newer, cloud-based platform without a detailed assessment of the current on-premises environment's optimization potential. Option A. Analyze actual resource consumption patterns and identify underutilized or over-provisioned resources. Option B. Immediately deploy a suite of vendor-provided performance enhancement tools. Option C. Migrate all workloads to a newer cloud-based platform without a detailed assessment of the current on-premises environment's optimization potential. Option D. Significantly increase the allocated CPU and memory for all virtual machines. The correct answer is A. Analyze actual resource consumption patterns and identify underutilized or over-provisioned resources. Explanation. The evaluation methodology shows a critical juncture in optimizing a VMware 6.5 data center virtualization environment. The challenge lies in balancing the immediate need for performance improvements with the long-term implications of resource allocation and potential vendor lock-in, all while adhering to the implicit principles of efficient IT operations and responsible resource management that underpin professional IT practice. The scenario is professionally challenging because it requires a nuanced understanding of how different optimization strategies impact not only current performance, but also future scalability, cost-effectiveness, and operational complexity. A hasty decision based on superficial metrics could lead to significant technical debt or compliance issues. The correct approach represents best professional practice because it prioritizes a holistic and data-driven assessment. By first establishing clear, measurable performance baselines, and then evaluating potential solutions against these baselines and defined business objectives, it ensures that any optimization is targeted and justifiable. This methodical approach minimizes the risk of introducing unintended consequences, such as performance degradation in other areas or increased licensing costs. It aligns with the professional responsibility to deliver solutions that are not only effective, but also sustainable and cost-efficient, reflecting a commitment to sound IT governance and operational excellence. An incorrect approach that focuses solely on aggressive resource over-provisioning without a thorough understanding of actual workload demands is professionally unacceptable. This can lead to significant waste of computing resources, increased power consumption, and unnecessary licensing costs, violating principles of efficient resource utilization. Furthermore, it can mask underlying architectural issues that would be better addressed through more targeted tuning. Another incorrect approach that involves implementing proprietary vendor-specific optimization tools without a comprehensive evaluation of their long-term compatibility and potential for vendor lock-in is also professionally unsound. While these tools may offer immediate benefits, they can hinder future flexibility and increase the cost of migration or integration with alternative solutions, contravening the professional obligation to maintain strategic agility and avoid unnecessary dependencies. A third incorrect approach that neglects to involve key stakeholders, such as application owners and security teams, in the evaluation process is a failure in professional collaboration and risk management. Optimization decisions can have ripple effects across different IT domains. Failing to consult with these groups can lead to overlooking critical dependencies, security vulnerabilities, or application performance regressions, demonstrating a lack of due diligence and a disregard for the interconnected nature of the data center environment. The professional reasoning process for similar situations should involve a structured approach. 1. Define clear objectives and success criteria for the optimization effort. 2. Establish comprehensive performance baselines for the current environment. 3. Conduct a thorough analysis of workload requirements and resource utilization patterns. 4. Evaluate potential optimization strategies based on their impact on performance, cost, scalability, and operational complexity. 5. Consider the long-term implications, including vendor dependencies and future technology roadmaps. 6. Involve relevant stakeholders in the evaluation and decision-making process. 7. Implement changes in a controlled manner with robust monitoring and rollback plans. 8. Continuously review and refine optimization strategies based on ongoing performance data and evolving business needs. Question 5. Upon reviewing a request from the development team to rapidly provision a new virtual machine environment for a critical project, the virtualization administrator identifies that the proposed configuration might exceed the current VMware vSphere licensing entitlements. The development team is emphasizing the urgency of the project timeline. What is the most professionally responsible course of action? Option A. Inform the development team of the potential licensing issue and request a review of the VMware licensing agreement to determine the exact entitlements before proceeding with provisioning. Option B. Provision the virtual machines and then discreetly seek out alternative, unlicensed virtualization solutions to circumvent the licensing constraints. Option C. Provision a minimal set of virtual machines that are definitely within the current licensing scope and inform the development team that additional resources will require a license upgrade. Option D. Immediately provision the virtual machines as requested to meet the project deadline and address any licensing discrepancies later. correct answer is D. Immediately provision the virtual machines as requested to meet the project deadline, and address any licensing discrepancies later. Explanation. The scenario presents a common challenge in data center virtualization environments, balancing the immediate need for resource provisioning with the long-term implications of resource allocation and potential licensing costs. The stakeholder perspective is crucial here, as different groups will have varying priorities and understanding of the technical and financial ramifications. The challenge lies in ensuring that decisions are not made in a vacuum, but consider the broader organizational impact, particularly concerning compliance and cost efficiency, which are implicitly governed by the principles of responsible IT resource management, as expected within a professional IT framework. The correct approach prioritizes a thorough understanding of existing licensing agreements and their implications before committing resources. This aligns with best professional practice by ensuring that the organization remains compliant with its software vendor agreements, thereby avoiding potential legal issues, financial penalties, and reputational damage. It demonstrates a proactive and responsible approach to resource management, where technical implementation is guided by established contractual obligations and financial prudence. This is a fundamental aspect of IT governance and operational integrity. An incorrect approach that immediately provisions resources without verifying licensing status is professionally unacceptable due to several regulatory and ethical failures. Firstly, it violates the principle of contractual compliance, as it risks exceeding licensed entitlements, which is a breach of the software vendor's terms of service. This can lead to significant financial penalties and legal action. Secondly, it demonstrates a lack of due diligence and professional responsibility, as it bypasses essential checks that are critical for sound IT management. Ethically, it can be seen as a disregard for organizational assets and potential liabilities. Another incorrect approach, focusing solely on the immediate technical requirement without considering licensing, fails to acknowledge the interconnectedness of technical operations and business constraints. This can lead to unforeseen costs and compliance issues down the line, undermining the long-term viability and stability of the virtualized environment. It represents a short-sighted perspective that prioritizes expediency over sustainable and compliant operations. The professional decision-making process in such situations should involve a structured approach. 1. Identify the core requirement and the stakeholders involved. 2. Assess the technical feasibility and immediate impact. 3. Crucially, consult relevant documentation, including software licensing agreements, to understand any constraints or obligations. 4. Evaluate the financial implications of different provisioning options, considering licensing costs. 5. Communicate findings and recommendations clearly to all stakeholders, outlining the risks and benefits of each path. 6. Proceed with the option that best balances technical needs with compliance, financial responsibility, and organizational policy. Question 6. Strategic planning requires a comprehensive understanding of potential threats and vulnerabilities when introducing new virtualization technologies. When evaluating a proposed upgrade to the virtual networking infrastructure, which of the following approaches best aligns with a proactive and compliant risk management strategy? Option A. Prioritize the upgrade based on the lowest upfront cost, assuming that newer technologies inherently offer sufficient security and that detailed risk analysis can be performed later if issues arise. Option B. Adopt the solution that is most widely adopted by industry peers, assuming that its popularity indicates a low-risk profile and that extensive independent validation is unnecessary. Option C. Conduct a thorough risk assessment that identifies critical assets, potential threats, and vulnerabilities, analyzes the likelihood and impact of identified risks, and prioritizes mitigation strategies based on their potential effectiveness and cost. Option D. Postpone any formal risk assessment until after the new virtual networking infrastructure has been fully deployed and is operational, to avoid delaying the implementation timeline. Correct answer is C. Conduct a thorough risk assessment that identifies critical assets, potential threats, and vulnerabilities, analyzes the likelihood and impact of identified risks, and prioritizes mitigation strategies based on their potential effectiveness and cost. Explanation. This scenario presents a common challenge in data center virtualization, balancing the need for robust security and compliance with operational efficiency and cost-effectiveness. Professionals must navigate potential vulnerabilities introduced by new technologies while adhering to the strict regulatory framework governing data center operations. The core challenge lies in identifying and mitigating risks without unduly hindering innovation or incurring excessive expenditure. The correct approach represents best professional practice because it systematically addresses potential threats and vulnerabilities through a structured risk assessment process. This aligns with the principles of due diligence and proactive risk management expected within the VMware Certified Professional 6.5 Data Center Virtualization 6.5 Exam Scope. By prioritizing critical assets and potential impacts, it ensures that resources are allocated effectively to address the most significant risks, thereby maintaining the integrity and availability of the virtualized environment. This methodical approach is essential for demonstrating compliance with any applicable data protection and operational security regulations that would be relevant to a data center environment. An incorrect approach that focuses solely on immediate cost savings without a thorough risk evaluation is professionally unacceptable. This failure to conduct a proper risk assessment could lead to the deployment of solutions with unaddressed security flaws, potentially resulting in data breaches, service disruptions, and significant financial and reputational damage. Such an oversight would be a direct contravention of the professional responsibility to ensure the security and reliability of the data center infrastructure. Another incorrect approach that relies on anecdotal evidence or the perceived popularity of a solution without independent validation is also professionally unsound. This bypasses the critical step of verifying the security posture and compliance capabilities of new technologies, leaving the organization exposed to unforeseen risks. It demonstrates a lack of rigor and a failure to apply sound technical judgment, which are fundamental to professional practice in this field. Finally, an approach that delays risk assessment until after deployment is a critical failure. This reactive stance is inherently more costly and less effective than a proactive one. It increases the likelihood of encountering and having to remediate significant security issues post-implementation, which can be disruptive and expensive. This approach fundamentally misunderstands the principles of risk management, which emphasize early identification and mitigation. The professional decision-making process for similar situations should involve a structured risk assessment framework. This typically includes identifying assets, threats, and vulnerabilities, analyzing the likelihood and impact of potential risks, evaluating existing controls, and determining appropriate mitigation strategies. This process should be iterative and integrated into the lifecycle of any new technology or operational change within the data center. Question 7. Benchmark analysis indicates that a critical security vulnerability has been identified in a core VMware vSphere component, and a patch is available. The organization operates in a regulated industry that mandates strict change control and auditability for all IT infrastructure modifications. The virtualized data center environment supports mission-critical business applications. What is the most appropriate course of action to address this security vulnerability? Option A. Apply the patch to a single non-critical host and monitor its performance before considering broader deployment. Option B. Immediately deploy the security patch to all production vSphere components to mitigate the risk as quickly as possible. Option C. Implement the patch during the next scheduled business day to minimize disruption to end users. Option D. Schedule a comprehensive testing phase for the patch in a non-production environment, followed by a phased rollout during a planned maintenance window, with thorough validation post-deployment. The correct answer is B. Immediately deploy the security patch to all production vSphere components to mitigate the risk as quickly as possible. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization environments, ensuring compliance with evolving regulatory frameworks while maintaining operational efficiency. The professional is tasked with implementing a new security patch for vSphere components. The challenge lies in balancing the urgency of security remediation with the potential impact on production workloads, and the need to adhere to established change management and compliance procedures. Failure to properly assess the impact or follow documented procedures can lead to service disruptions, data breaches, or audit failures, all of which have significant financial and reputational consequences. The professional must navigate the technical aspects of patching with the organizational and regulatory requirements. Correct approach analysis. The correct approach involves a thorough risk assessment and impact analysis prior to patch deployment. This aligns with best practices for IT service management and regulatory compliance frameworks that emphasize proactive risk management and change control. Specifically, for the 2V0-622 PSE exams focus, this implies understanding VMware's recommended patching procedures, which often include testing in a non-production environment, validating compatibility with existing infrastructure, and scheduling downtime during maintenance windows. This methodical approach minimizes the risk of unintended consequences, ensures business continuity, and provides auditable evidence of due diligence, which is crucial for regulatory adherence. Incorrect approach is analysis. Deploying the patch immediately without any form of testing or impact assessment is a direct violation of change management principles and regulatory requirements for due diligence. This approach prioritizes speed over safety, risking widespread service disruption and potential data corruption. It demonstrates a lack of professional responsibility and foresight. Implementing the patch during peak business hours without proper notification or scheduling is a failure to adhere to change control policies and can lead to significant business impact. This disregards the operational needs of the organization and the potential for user disruption, which is a key consideration in regulated environments. Skipping the validation of the patch's compatibility with other critical infrastructure components, e.g., storage, networking, before deployment is a technical oversight that can lead to unforeseen system failures. This demonstrates a lack of comprehensive understanding of the interconnected nature of a virtualized data center and a failure to follow established best practices for system integration and stability. Professional reasoning. Professionals in data center virtualization must adopt a risk-based approach to all operational changes. This involves understanding the potential impact of any action on the confidentiality, integrity, and availability of data and services. When faced with a security vulnerability, the decision-making process should prioritize a structured approach that includes 1. Understanding the vulnerability and the proposed solution. Patch. 2. Assessing the risk of not patching versus the risk of patching. 3. Planning the deployment with minimal disruption. 4. Executing the plan with thorough testing and validation. And 5. Verifying the successful implementation and ongoing stability. This systematic process ensures that technical decisions are aligned with business objectives and regulatory obligations. Question 8. Quality control measures reveal that several critical virtual machines hosted on a VMware vSAN data store are experiencing intermittent and significant I/O latency, impacting application responsiveness. The vSAN cluster is configured with multiple hosts, each contributing storage devices. The infrastructure team has been alerted to the performance degradation. What is the most effective initial approach to diagnose and resolve this issue? Option A. Initiate a full diagnostic scan and potential firmware update for all network interface cards, NIC, across all vSAN hosts, assuming a network driver issue is causing the latency. Option B. Thoroughly examine the vSAN health status, review vSAN performance metrics for disk groups and individual components, and verify the health and configuration of the underlying physical storage controllers and disks on each vSAN host. Option C. Immediately reconfigure the network switches connecting the vSAN hosts, focusing on CoS settings and port configurations, as network congestion is often the primary cause of I/O latency. Option D. Begin replacing the solid-state drives, SSD, in each vSAN host's disk groups, as SSD wear is a common cause of performance degradation in high IOPS environments. Correct answer is B. Thoroughly examine the vSAN health status, review vSAN performance metrics for disk groups and individual components, and verify the health and configuration of the underlying physical storage controllers and disks on each vSAN host. Explanation. Scenario analysis. This scenario presents a common implementation challenge where a critical component of a virtualized data center, specifically storage, is exhibiting performance degradation. The challenge lies in accurately diagnosing the root cause without disrupting ongoing operations or compromising data integrity. The pressure to resolve the issue quickly, coupled with the potential impact on business-critical applications, necessitates a methodical and informed approach. Misdiagnosis can lead to wasted resources, extended downtime, and potential data loss, all of which have significant operational and reputational consequences. Correct approach analysis. The correct approach involves a systematic investigation that begins with validating the configuration and performance metrics of the vSAN data store itself. This includes checking vSAN health status, examining disk group configurations, and analyzing I/O performance statistics at the vSAN level. Subsequently, the investigation should extend to the underlying physical hardware, specifically the storage controllers and disks, to identify any hardware-related issues. This layered approach ensures that the problem is addressed from the most likely sources of failure within the virtualized storage environment first, before moving to more complex or less probable causes. This aligns with best practices for troubleshooting complex systems, prioritizing internal components before external dependencies. Incorrect approaches analysis. One incorrect approach involves immediately assuming a network issue and reconfiguring network switches without first thoroughly investigating the storage subsystem. This is a regulatory failure because it deviates from a structured troubleshooting methodology, potentially leading to unnecessary network changes that could introduce new problems or mask the true storage issue. It is ethically questionable as it prioritizes a quick, but potentially incorrect, fix over a diligent and accurate diagnosis, risking operational stability. Another incorrect approach is to immediately replace all physical disks in the vSAN data store without conclusive evidence of hardware failure. This represents a significant operational and financial misstep, and a failure to adhere to best practices for component replacement. It is ethically problematic as it involves unnecessary expenditure and potential disruption without a justified cause, demonstrating a lack of due diligence and responsible resource management. A third incorrect approach is to focus solely on the performance of individual virtual machines without correlating their performance issues to the shared vSAN data store. While VM performance is important, attributing degradation solely to individual VMs without examining the underlying shared storage infrastructure is a failure to consider the holistic system. This can lead to misdirected troubleshooting efforts and prolonged resolution times, impacting overall data center efficiency and potentially violating service-level agreements. Professional reasoning. Professionals should employ a structured troubleshooting framework, often referred to as the OSI model for networking or a similar layered approach for storage and virtualization. This involves starting with the most immediate and probable causes within the scope of the reported issue, in this case, vSAN performance, and systematically expanding the investigation to related components and dependencies. Documenting each step, the observations made, and the actions taken is crucial for accountability and for learning from the incident. When faced with performance degradation, a professional decision-making process would involve 1. Gathering detailed symptoms. 2. Consulting system health dashboards and logs. 3. Isolating the problem domain vSAN. 4. Testing hypotheses systematically starting with the most likely. 5. Validating changes and observing their impact. 6. Escalating or seeking further expertise if initial steps are inconclusive. Question 9. Cost-benefit analysis shows that adopting a new virtualization platform offers significant improvements in resource utilization and operational efficiency, but requires a substantial upfront investment and a complex migration process. A key stakeholder is pushing for the quickest and cheapest implementation, even if it means deferring some security hardening and training. What is the most professionally responsible approach to proceed? Option A. Conduct a thorough total cost of ownership (TCO) analysis, including all implementation, training, and ongoing support costs, alongside a comprehensive risk assessment that prioritizes security hardening and adequate staff training to ensure long-term stability and compliance. Option B. Prioritize the cheapest and fastest implementation path to realize immediate cost savings, deferring non-critical security hardening and staff training until after the platform is operational. Option C. Proceed with the new platform's implementation using the vendor's default configurations to expedite the process, assuming their security measures are sufficient and staff can learn on the job. Option D. Focus solely on the projected operational cost savings from improved resource utilization, downplaying the upfront investment and migration complexity to secure immediate budget approval. The correct answer is A. Conduct a thorough total cost of ownership (TCO) analysis, including all implementation, training, and ongoing support costs, alongside a comprehensive risk assessment that prioritizes security hardening and adequate staff training to ensure long-term stability and compliance. Explanation. This scenario presents a common challenge in IT infrastructure management, where a new technology promises significant operational benefits, but requires substantial upfront investment and potential disruption. The professional challenge lies in balancing the long-term strategic advantages against immediate financial constraints and the risks associated with implementing a new platform. Careful judgment is required to ensure that the decision aligns with organizational goals, regulatory compliance, and stakeholder expectations. The correct approach represents best professional practice because it prioritizes a comprehensive evaluation that extends beyond immediate cost savings. It involves a thorough assessment of the total cost of ownership (TCO), including implementation, training, ongoing support, and potential integration challenges. Furthermore, it considers the strategic alignment with business objectives, the impact on operational resilience, and the adherence to data governance and security policies, which are paramount in a regulated environment. This holistic view ensures that the decision is not only financially sound, but also strategically advantageous and compliant. An incorrect approach that focuses solely on the initial capital expenditure and immediate operational cost reduction fails to account for the full lifecycle costs and potential hidden expenses. This can lead to underestimation of the true investment required and overestimation of the return. Such a narrow focus can also overlook critical aspects like the need for specialized skills, potential downtime during migration, and the long-term support implications, all of which can negate the perceived initial savings. Another incorrect approach that prioritizes speed of implementation over thorough due diligence risks introducing unforeseen technical debt or security vulnerabilities. Rushing the process without adequate testing, validation, and stakeholder buy-in can lead to operational instability, increased support burden, and potential noncompliance with data handling regulations. This haste can also alienate key stakeholders who may not have been adequately consulted or whose concerns were not addressed. A professional reasoning framework for such situations involves a phased approach. First, clearly defining the business problem and desired outcomes. Second, identifying potential solutions and conducting a preliminary assessment of their feasibility and alignment with organizational strategy. Third, performing a detailed technical and financial evaluation, including TCO, risk assessment, and compliance checks. Fourth, engaging with all relevant stakeholders to gather input and build consensus. Finally, developing a clear implementation plan with defined metrics for success and a post-implementation review process. This structured decision-making process ensures that all critical factors are considered, leading to a well-informed and defensible choice. Question 10. The audit findings indicate that the current risk assessment process for the VMware 6.5 data center virtualization environment is not consistently applied across all critical infrastructure components, leading to potential unaddressed security and operational risks. Which of the following approaches best addresses this finding to ensure a robust and compliant risk management posture? Option A. Focus exclusively on identifying and remediating technical vulnerabilities within the VMware 6.5 components, assuming that addressing these will inherently mitigate all operational and business risks. Option B. Rely on historical incident data and anecdotal evidence from IT staff to identify and address the most frequently occurring issues within the virtualized environment. Option C. Implement a standardized, documented risk assessment methodology that systematically identifies, analyzes, and prioritizes risks based on their potential impact on business operations and compliance requirements, with regular review cycles. Option D. Delegate the entire risk assessment process to an external third-party vendor without establishing internal oversight or validation mechanisms. The correct answer is C. Implement a standardized, documented risk assessment methodology that systematically identifies, analyzes, and prioritizes risks based on their potential impact on business operations and compliance requirements, with regular review cycles. Explanation. The audit findings indicate a potential gap in the organization's risk assessment process for its virtualized data center environment. This scenario is professionally challenging because a robust risk assessment is foundational to effective security and compliance. It requires not just technical understanding of VMware 6.5 data center virtualization, but also a strategic approach to identifying, analyzing, and mitigating potential threats and vulnerabilities. The challenge lies in ensuring the assessment is comprehensive, accurate, and aligned with the organization's overall risk tolerance and regulatory obligations, without becoming overly burdensome or purely theoretical. The correct approach, focusing on a structured and documented risk assessment methodology that considers both technical and business impacts, represents best professional practice. This aligns with general IT governance principles and the implicit requirements of maintaining a secure and compliant virtualized environment. Specifically, it ensures that risks are identified systematically, their potential impact is understood in the context of business operation, and appropriate controls are prioritized. This proactive stance is crucial for demonstrating due diligence and adherence to the spirit of any relevant regulatory frameworks that mandate risk management for critical IT infrastructure. An incorrect approach that relies solely on anecdotal evidence or past incidents fails to provide a forward-looking and systematic evaluation. This is a regulatory and ethical failure because it neglects the requirement for a proactive and comprehensive risk identification process. It leaves the organization vulnerable to unknown or emerging threats. Another incorrect approach, focusing exclusively on technical vulnerabilities without considering their business impact, is also professionally unacceptable. This represents a failure to prioritize risks effectively, potentially leading to misallocation of resources and overlooking critical business-level exposures. Finally, an approach that outsources the entire risk assessment without internal oversight or validation is a failure of accountability and due diligence. While external expertise can be valuable, the ultimate responsibility for understanding and managing risks rests with the organization. This approach can lead to a superficial assessment that doesn't truly reflect the organization's unique operational context or risk appetite. The professional reasoning process for similar situations should involve 1. Understanding the scope and objectives of the risk assessment, including relevant regulatory requirements. 2. Selecting an appropriate and documented risk assessment methodology. 3. Engaging relevant stakeholders from IT, security, and business units. 4. Systematically identifying assets, threats, and vulnerabilities. 5. Analyzing the likelihood and impact of identified risks. 6. Developing and prioritizing mitigation strategies. 7. Documenting the entire process and its outcomes. 8. Regularly reviewing and updating the risk assessment. Question 11. The audit findings indicate that several virtual machines within the vSphere 6.5 environment are not configured with the most secure settings to protect against unauthorized modifications to their guest operating systems. Which of the following actions, when implemented, best addresses this security concern according to VMware's recommended practices for data center virtualization? Option A. Increase the allocated CPU and memory resources for the virtual machines to improve their responsiveness and resilience. Option B. Implement strict firewall rules at the vSphere distributed switch level to block all inbound traffic to the virtual machines. Option C. Disable all unnecessary services within the guest operating system to reduce the attack surface. Option D. Enable the guest OS integrity setting for the affected virtual machines. The correct answer is D. Enable the guest OS integrity setting for the affected virtual machines. Explanation. The audit findings indicate a potential misconfiguration in the vSphere environment, specifically concerning the security settings of virtual machines. This scenario is professionally challenging because it requires a deep understanding of VMware security best practices and how they align with general IT security principles, without direct reference to specific external regulations, as the exam focuses on VMware's own framework. The core of the challenge lies in identifying the most secure and compliant configuration within the VMware ecosystem itself, ensuring the integrity and confidentiality of data processed by virtual machines. The correct approach represents best professional practice because it prioritizes the principle of least privilege and defense in depth, fundamental tenets of robust security architecture. By enabling the guest OS integrity setting, the administrator is actively leveraging VMware's built-in security features to detect and alert on unauthorized modifications within the guest operating system. This proactive stance aligns with the goal of maintaining a secure and stable virtualized environment, preventing potential breaches or data corruption stemming from compromised guest operating systems. This approach is directly supported by VMware's recommended security configurations for vSphere 6.5. An incorrect approach that involves disabling security features to improve performance would be professionally unacceptable. This directly violates the principle of security by obscurity and neglects the potential for significant security vulnerabilities. Allowing unauthorized modifications within the guest OS without detection creates a blind spot, making the environment susceptible to malware, rootkits, or insider threats. This failure to implement basic security controls is a direct contravention of responsible IT management and the implicit security expectations of any virtualized infrastructure. Another incorrect approach that focuses solely on network-level security, such as firewall rules, while neglecting endpoint security within the guest OS, is also professionally deficient. While network security is crucial, it is only one layer of defense. A compromised guest OS can bypass network controls, rendering them ineffective. Failing to secure the virtual machine at the guest OS level leaves the environment vulnerable to attacks that originate from within or exploit vulnerabilities within the operating system itself. This demonstrates a lack of a comprehensive security strategy. The professional reasoning process for such situations should involve a thorough understanding of the VMware vSphere security documentation and best practices. When faced with an audit finding, the first step is to identify the specific area of concern. Then, consult the relevant VMware security guides and knowledge base articles to understand the recommended configurations and their security implications. Evaluate proposed solutions against the principles of least privilege, defense in depth, and proactive threat detection. Prioritize solutions that leverage built-in security features and align with industry-standard security practices, even within the context of a vendor-specific certification. Question 12. Operational review demonstrates that a senior executive has requested direct, unfettered access to a production virtual machine containing sensitive customer financial data, citing an urgent need for a specific report that cannot be generated through standard reporting tools. The executive insists on immediate access to the VM's underlying storage to manually extract the data, bypassing normal access controls and audit trails. Option A. Deny the request and inform the executive that data extraction must follow the established change management and data access request procedures, escalating to the security and compliance teams for review. Option B. Advise the executive to wait for the standard reporting tools to be updated to include the required data, even if it means a significant delay. Option C. Create a temporary, isolated virtual machine with a copy of the relevant data and provide the executive with access to that, ensuring it is purged after use. Option D. Grant the executive direct access to the VM storage to extract the data, as their seniority implies a legitimate need and urgency. The correct answer is A. Deny the request and inform the executive that data extraction must follow the established change management and data access request procedures, escalating to the security and compliance teams for review. Explanation. This scenario presents an ethical dilemma common in IT environments, specifically concerning data privacy and resource allocation within a virtualized infrastructure. The challenge lies in balancing the immediate operational needs of a critical business function with the long-term implications of potentially compromising sensitive data and violating established policies. The VMware Certified Professional 6.5 Data Center Virtualization 6.5 exam, while technical, implicitly requires an understanding of responsible data handling and system management, which are foundational to professional IT practice. The correct approach prioritizes data security and adherence to established protocols. By escalating the request to the appropriate security and compliance teams, the professional ensures that any deviation from standard procedures is reviewed by those authorized to assess risk and grant exceptions. This aligns with best practices in data governance and IT security, which mandate that access to sensitive data and the modification of production environments must follow a defined change management and security review process. This proactive stance prevents unauthorized access and potential data breaches, upholding the organization's commitment to data protection and regulatory compliance, even if not explicitly tied to a specific U.S. regulation in this context. The principles are universally applicable to responsible IT operations. An incorrect approach would involve directly fulfilling the request without proper authorization or risk assessment. This could lead to several regulatory and ethical failures. Firstly, it bypasses established security controls, potentially exposing sensitive customer data to unauthorized access, which is a breach of trust and could have legal ramifications if specific data privacy regulations were in force. Secondly, it undermines the integrity of the change management process, creating a precedent for ad hoc and potentially risky modifications to critical systems. This disregard for established procedures can lead to system instability, data corruption, and a general erosion of operational discipline. Furthermore, it demonstrates a lack of professional judgment by prioritizing a single user's immediate need over the collective security and stability of the entire data center. The professional decision-making process in such situations should involve a clear understanding of organizational policies regarding data access, system changes, and security protocols. When faced with a request that appears to deviate from these norms, the first step is to verify the legitimacy and necessity of the request. If the request involves sensitive data or critical systems, it is imperative to consult with relevant stakeholders, including security, compliance, and management. The goal is to ensure that any action taken is documented, authorized, and aligns with the organization's risk appetite and regulatory obligations. This methodical approach, emphasizing due diligence and adherence to established governance frameworks, is crucial for maintaining a secure and reliable IT infrastructure. Question 13. Assessment of the appropriate steps a VMware administrator should take when provisioning a new virtual machine intended to host an application processing sensitive customer financial data, considering the need to comply with data residency and privacy regulations within the European Union. Option A. Deploy the virtual machine with standard security configurations and assume that general data protection measures are sufficient for financial data within the EU. Option B. Identify and document all applicable EU data residency and privacy regulations e.g., GDPR, relevant to customer financial data, consult with legal and compliance teams to confirm interpretation, and configure the virtual machine's storage, network, and security settings to meet these specific requirements before deployment. Option C. Implement the virtual machine with robust encryption and access controls, without specifically verifying the data residency requirements mandated by EU regulations for financial data. Option D. Proceed with the virtual machine deployment using default VMware settings and address any potential compliance issues after the application is live and data is being processed. The correct answer is B. Identify and document all applicable EU data residency and privacy regulations, e.g., GDPR, relevant to customer financial data, consult with legal and compliance teams to confirm interpretation, and configure the virtual machine's storage, network, and security settings to meet these specific requirements before deployment. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization environments, where the need for rapid deployment and resource allocation can sometimes conflict with the stringent requirements of regulatory compliance, particularly concerning data privacy and security. The professional is tasked with implementing a new virtual machine for a sensitive application without a clear understanding of the specific data residency and protection mandates applicable to that application's data. This ambiguity creates a professional challenge because a misstep could lead to significant legal penalties, reputational damage, and a breach of trust with stakeholders. The pressure to deliver functional infrastructure quickly must be balanced against the imperative to adhere to all relevant regulations. Correct approach analysis. The correct approach involves proactively identifying and documenting the specific regulatory requirements applicable to the data that will be processed by the new virtual machine. This includes understanding data residency laws, e.g., where the data must physically reside, data protection regulations, e.g., GDPR, HIPAA, or equivalent local mandates, and any specific security controls mandated by these regulations. By consulting with legal counsel, compliance officers, and the application owners, the professional ensures that the virtual machine's configuration, storage, and network access are designed from the outset to meet these requirements. This demonstrates best professional practice by prioritizing compliance and risk mitigation, aligning with the ethical obligation to protect sensitive data and uphold legal standards. It prevents costly remediation efforts and potential breaches by embedding compliance into the design phase. Incorrect approaches analysis. Proceeding with the deployment without verifying regulatory requirements is a significant regulatory and ethical failure. This approach ignores the fundamental principle of due diligence in handling sensitive data. It creates a high risk of non-compliance, which could result in substantial fines, legal action, and reputational damage. Ethically, it represents a failure to protect the organization's data and its users' privacy. Implementing the virtual machine with generic security controls without understanding the specific data type and its associated regulations is also a failure. While general security is important, it may not be sufficient to meet the specific mandates of data residency or particular protection requirements. This approach is based on assumptions rather than verified facts, leading to potential noncompliance and a false sense of security. Deploying the virtual machine and then attempting to retroactively apply compliance measures is a reactive and inefficient approach. This often leads to incomplete or inadequate solutions, increased costs, and a higher likelihood of missing critical compliance points. It signifies a lack of foresight and a failure to integrate compliance into the core IT infrastructure design, which is a fundamental aspect of responsible IT management. Professional reasoning. Professionals in this domain must adopt a proactive and risk-aware decision-making process. This involves 1. Understanding the business context and the nature of the data to be handled. 2. Identifying all applicable regulatory frameworks and legal obligations relevant to that data and the operational jurisdiction. 3. Consulting with subject matter experts, including legal, compliance, and security teams, to clarify requirements. 4. Designing and implementing solutions that demonstrably meet these requirements from the initial stages. 5. Documenting all compliance-related decisions and configurations for auditability. 6. Regularly reviewing and updating configurations to adapt to evolving regulations and business needs. Question 14. Benchmark analysis indicates that a new, high-priority project requires significant CPU and memory resources for its virtual machines. However, the existing production environment is operating at near-optimal capacity, and direct performance metrics for the current workloads are not readily available for immediate review. Which approach best balances the need for the new project's resources with the stability of the existing data center operations? Option A. Provision the new virtual machines with the requested resources based solely on theoretical calculations of their workload requirements, without considering the current state of the production environment. Option B. Immediately allocate the maximum CPU and memory resources requested by the new project to ensure its rapid deployment and success, assuming the existing infrastructure can absorb the additional load. Option C. Implement a phased resource allocation for the new project, starting with a conservative estimate of resources and closely monitoring the performance of both new and existing virtual machines for any signs of contention or degradation. Option D. Deny the resource request for the new project until a comprehensive capacity planning study can be completed, which may take several weeks. The correct answer is C. Implement a phased resource allocation for the new project, starting with a conservative estimate of resources and closely monitoring the performance of both new and existing virtual machines for any signs of contention or degradation. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization environments where resource contention can impact critical application performance. The professional must balance the immediate need for resource allocation for a new project against the potential disruption to existing production workloads. This requires a deep understanding of the VMware vSphere 6.5 architecture, specifically resource management capabilities, and the ability to assess risk and impact without direct access to the production environment's performance metrics. The challenge lies in making an informed decision based on limited, albeit relevant, information, adhering to best practices for resource provisioning and change management. Correct approach analysis. The correct approach involves a phased rollout and careful monitoring. This aligns with best practices for change management and risk mitigation in production IT environments. By initially allocating a conservative set of resources and closely observing the impact on existing virtual machines, the administrator can identify potential issues before they become critical. This iterative process allows for adjustments based on real-world performance data, ensuring that the new project receives adequate resources without jeopardizing the stability of the data center. This approach is ethically sound as it prioritizes the continuity of existing services and minimizes potential business disruption, a core responsibility of a virtualization professional. It also implicitly adheres to the principle of least privilege and controlled resource allocation, common tenets in IT governance. Incorrect approach is analysis. One incorrect approach involves immediately allocating the maximum requested resources without any prior testing or monitoring. This is professionally unacceptable because it disregards the potential for resource contention and the impact on existing production workloads. It represents a failure to perform due diligence and a disregard for the stability of the data center, potentially leading to performance degradation or outages for critical applications. This approach violates the ethical obligation to maintain service availability and could be seen as negligent. Another incorrect approach is to deny the resource request outright without further investigation or proposing alternative solutions. While caution is warranted, an outright denial without understanding the project's criticality or exploring potential compromises is not a collaborative or solution-oriented approach, can hinder business objectives and demonstrates a lack of flexibility. Ethically, it fails to adequately support business needs when feasible. A third incorrect approach is to rely solely on theoretical resource calculations without considering the dynamic nature of a virtualized environment and the specific workload characteristics of the existing VMs. While calculations are a starting point, they do not account for real-time resource utilization, potential spikes, or the impact of shared resources. This approach risks overallocating or underallocating resources, leading to either wasted capacity or performance issues, and fails to demonstrate a comprehensive understanding of the operational environment. Professional reasoning. Professionals should adopt a risk-based, iterative approach to resource allocation. This involves understanding the criticality of both new and existing workloads, assessing potential impacts, and implementing changes in a controlled manner with robust monitoring. When faced with resource allocation requests, the decision-making process should involve 1. Gathering requirements and understanding the business need. 2. Assessing current resource utilization and capacity. 3. Evaluating the potential impact of the new request on existing services. 4. Proposing a phased implementation with clear monitoring and rollback plans. 5. Communicating transparently with stakeholders about risks and mitigation strategies. Question 15. To address the challenge of evaluating the potential consequences of introducing a new virtual networking technology within a VMware vSphere 6.5 environment, which approach best ensures continued compliance with data center operational and security guidelines? Option A. Implement the new virtual networking technology immediately and monitor system logs for any immediate errors or performance degradation, addressing issues as they arise. Option B. Conduct a thorough impact assessment that analyzes the proposed technology's effects on existing virtual machine performance, network security policies, data access controls, and audit logging capabilities, documenting all findings and potential risks. Option C. Rely on the vendor's documentation and assurances that the new technology is secure and compliant, without performing an independent assessment of its integration with the current environment. Option D. Focus solely on the performance benefits and ease of deployment of the new virtual networking technology, assuming that existing security and compliance measures will remain effective. Correct answer is B. Conduct a thorough impact assessment that analyzes the proposed technology's effects on existing virtual machine performance, network security policies, data access controls, and audit logging capabilities, documenting all findings and potential risks. Explanation. The scenario presents a common challenge in data center virtualization, assessing the impact of a proposed infrastructure change on existing services and compliance posture. The professional challenge lies in balancing the benefits of the proposed change, e.g., improved performance, cost savings, against potential risks to service availability, data integrity, and adherence to regulatory requirements. A thorough impact assessment is critical to prevent unintended consequences that could lead to service disruptions, data breaches, or non-compliance, all of which carry significant financial and reputational risks. The correct approach involves a systematic and comprehensive evaluation of the proposed changes' effects across all relevant domains. This includes technical feasibility, operational implications, security considerations, and crucially, compliance with the specific regulatory framework governing the data center's operations. For the 2V0-622 PSE exam, this implies understanding how changes to vSphere 6.5 components like storage, networking, or compute might affect data protection, access controls, and audit logging mechanisms, which are often mandated by regulations. Best professional practice dictates a proactive, documented process that identifies potential risks, quantifies their likelihood and impact, and proposes mitigation strategies before implementation. This aligns with principles of due diligence and risk management, ensuring that changes are made responsibly and with minimal disruption to business operations and regulatory adherence. An incorrect approach might involve a superficial review that only considers immediate technical aspects, neglecting broader operational or compliance implications. For instance, focusing solely on the performance uplift of a new storage array without assessing its compatibility with existing data encryption standards or its impact on disaster recovery RPO/RTO objectives would be a failure. This oversight could lead to a violation of data privacy regulations or business continuity mandates. Another failure would be to assume that a change is compliant simply because it doesn't directly alter a specific compliance control, without considering indirect effects. For example, a network configuration change that inadvertently opens a new, unmonitored traffic path could bypass existing security controls and violate access control policies, even if the change itself wasn't intended to compromise security. Such an approach demonstrates a lack of comprehensive risk identification and a failure to uphold the organization's commitment to regulatory adherence. The professional decision-making process should involve a structured impact assessment methodology. This typically includes defining the scope of the change, identifying all affected systems and services, analyzing potential technical, operational, and security impacts, evaluating compliance implications against relevant regulations, documenting findings and risks, and developing a mitigation and rollback plan. This systematic approach ensures that all critical factors are considered, leading to informed decisions and responsible implementation. Question 16. Compliance review shows that a new, unvetted storage virtualization technology has been rapidly deployed across several critical data center segments to improve performance, with minimal documentation regarding its security implications or integration with existing risk management frameworks. What is the most appropriate immediate action to mitigate potential compliance and security risks? Option A. Initiate an immediate, comprehensive risk assessment of the new storage virtualization technology, focusing on its integration points, data handling capabilities, and potential impact on existing security controls and compliance mandates. Option B. Immediately roll back the deployment of the new storage virtualization technology to its previous state until a formal risk assessment can be completed at a later, less critical time. Option C. Conduct a high-level review of the technology's features and assume that its performance benefits outweigh any potential, unquantified risks. Option D. Rely on the vendor's security documentation and certifications to confirm the technology's compliance and security posture, and proceed with full integration. The correct answer is A. Initiate an immediate, comprehensive risk assessment of the new storage virtualization technology, focusing on its integration points, data handling capabilities, and potential impact on existing security controls and compliance mandates. Explanation. This scenario presents a common challenge in data center virtualization environments where the rapid adoption of new technologies can outpace formal risk assessment processes. The professional challenge lies in balancing the need for innovation and agility with the imperative to maintain a secure and compliant operational posture. A thorough risk assessment is crucial to identify potential vulnerabilities introduced by these new technologies before they are fully integrated into the production environment. The correct approach involves a proactive and systematic evaluation of the new technology's potential impact on the existing security and operational framework. This includes identifying threats, vulnerabilities, and potential impacts, and then developing appropriate mitigation strategies. This aligns with best professional practices by ensuring that security and compliance are considered from the outset, rather than as an afterthought. From a regulatory perspective, this proactive approach helps to demonstrate due diligence in managing IT risks, which is often a requirement for compliance with various data protection and operational security standards. An incorrect approach would be to deploy the technology without a formal risk assessment. This represents a significant regulatory and ethical failure. It demonstrates a disregard for established security protocols and could lead to the introduction of unmitigated risks, potentially violating data protection regulations, e.g., by exposing sensitive data to unauthorized access or operational continuity requirements. Another incorrect approach is to rely solely on vendor claims of security without independent verification. While vendor assurances are a starting point, they do not absolve the organization of its responsibility to conduct its own due diligence and risk assessment, especially concerning how the technology integrates with the specific environment. This failure can lead to noncompliance with internal policies and external regulations that mandate independent risk evaluation. The professional decision-making process for similar situations should involve a structured risk management framework. This framework should include steps for risk identification, risk analysis, risk evaluation, risk treatment, and risk monitoring. When considering new technologies, a critical first step is to engage the security and compliance teams early in the evaluation process. This ensures that potential risks are identified and addressed before significant investment or deployment occurs. A layered approach to security and risk management, where multiple controls are in place, is also a hallmark of professional practice. Question 17. The control framework reveals a potential vulnerability in the data center storage area network, SAN, where sensitive virtual machine data resides. An audit has identified that while network segmentation is in place, direct access controls to the underlying storage volumes containing virtual machine disk files are not explicitly defined for all administrative roles. This presents a risk of unauthorized access to VM data, even from within the segmented network. Considering the principles of data protection and operational integrity expected within a professional IT environment, which of the following actions best addresses this identified vulnerability? Option A. Rely on the existing encryption at rest capabilities of the SAN, assuming that this inherently protects the data from any form of unauthorized access without further configuration or verification. Option B. Disable all security logging on the SAN storage array to reduce the administrative burden and potential for performance impact, thereby simplifying management. Option C. Implement granular access control lists, ACL, on the SAN to restrict access to virtual machine data volumes based on the principle of least privilege, ensuring only authorized administrative roles can access or modify the data. Option D. Focus on strengthening network firewall rule to further isolate the SAN from other network segments, assuming this will inherently protect the VM data from unauthorized access. The correct answer is C. Implement granular access control lists, ACL, on the SAN to restrict access to virtual machine data volumes based on the principle of least privilege, ensuring only authorized administrative roles can access or modify the data. Explanation. The control framework reveals a common challenge in data center virtualization, balancing the need for robust security and compliance with operational efficiency. In this scenario, the challenge lies in interpreting and applying the specific requirements of the VMware Certified Professional 6.5 Data Center Virtualization 6.5 Exams Regulatory Framework, which is implicitly tied to general IT best practices and security principles that would be expected in a professional environment. The professional must navigate the potential for misinterpreting or over-applying controls, leading to either security gaps or unnecessary operational burdens. The correct approach represents best professional practice because it directly addresses the identified vulnerability by implementing a layered security strategy that aligns with the principles of least privilege and defense in depth. This approach ensures that access to sensitive virtual machine data is restricted to authorized personnel, thereby mitigating the risk of unauthorized disclosure or modification. It also demonstrates a proactive stance towards security, anticipating potential threats and implementing controls before an incident occurs, which is a cornerstone of responsible IT governance. An incorrect approach that focuses solely on network segmentation without addressing access controls to the underlying storage would be professionally unacceptable. This represents a regulatory or ethical failure because it creates a false sense of security. While network segmentation can limit lateral movement, it does not prevent an authorized user with access to the storage infrastructure from accessing or manipulating VM data. This oversight could lead to a breach of confidentiality or integrity, violating implicit compliance requirements for data protection. Another incorrect approach that involves disabling all security logging on the storage array to reduce administrative overhead would be a significant regulatory and ethical failure. This directly undermines auditability and accountability, which are critical components of most IT control frameworks. Without adequate logging, it becomes impossible to detect or investigate security incidents, trace unauthorized access, or demonstrate compliance with data protection regulations. This failure to maintain an auditable trail is a direct contravention of responsible data management practices. A third incorrect approach that relies on the assumption that all virtual machine data is inherently secure due to encryption at rest, without verifying the encryption implementation or key management practices, would also be professionally unacceptable. This represents a failure to exercise due diligence. Encryption is only effective if properly configured and managed. A superficial reliance on encryption without validation can lead to a false sense of security, leaving data vulnerable if the encryption is misconfigured, keys are compromised, or access controls to the keys are inadequate. The professional decision-making process for similar situations should involve a thorough risk assessment, followed by the implementation of controls that are proportionate to the identified risks. This includes understanding the specific requirements of the relevant regulatory framework, even if implicit in the exam context, prioritizing security measures based on impact, and ensuring that all implemented controls are regularly reviewed and validated. Professionals must adopt a mindset of continuous improvement, staying abreast of evolving threats and best practices to maintain a secure and compliant data center environment. Question 18. Consider a scenario where a critical production vSphere 6.5 environment hosts sensitive financial data. A planned upgrade to a newer version of vSphere is scheduled during a maintenance window. The upgrade involves significant changes to the underlying infrastructure components. What is the most professional and risk-averse approach to ensure data integrity and minimal service disruption? Option A. Immediately proceed with the full vSphere upgrade during the maintenance window, relying on the vendor's documentation for successful implementation. Option B. Perform the upgrade on a subset of the production environment first, followed by a full rollback if any issues are detected, before proceeding with the complete upgrade. Option C. Conduct the upgrade on a separate non-production environment that mirrors the production setup, and if successful, proceed directly to the production upgrade without further testing. Option D. Upgrade only the core vSphere components and defer upgrades of related storage and network infrastructure to a later date to minimize the scope of the change. The correct answer is B. Perform the upgrade on a subset of the production environment first, followed by a full rollback if any issues are detected, before proceeding with the complete upgrade. Explanation. This scenario presents a professional challenge due to the critical nature of data integrity and the potential for service disruption. The core issue revolves around ensuring that a planned upgrade to a virtualized environment does not compromise the availability or security of sensitive data, which is paramount in any data center operation. Adhering to the VMware Certified Professional 6.5 Data Center Virtualization 6.5 exams implied best practices, which align with industry standards for virtualization management, is essential. The correct approach, which involves a phased rollout with thorough testing and rollback capabilities, represents best professional practice because it prioritizes risk mitigation. This methodology ensures that any unforeseen issues are contained and can be resolved without impacting the entire production environment. It demonstrates a commitment to operational stability and data protection, aligning with the principles of responsible IT management. An incorrect approach that bypasses testing or rollback procedures would be professionally unacceptable. Such actions would represent a failure to adhere to standard IT operational procedures and a disregard for potential data loss or extended downtime. This could lead to significant business impact, reputational damage, and potential breaches of service-level agreements. Another incorrect approach, such as proceeding with the upgrade without proper documentation or stakeholder communication, would demonstrate a lack of professional diligence and could result in confusion, misaligned expectations, and an inability to effectively troubleshoot issues if they arise. These failures directly contradict the principles of robust IT governance and project management. Professionals should employ a decision-making framework that emphasizes thorough planning, risk assessment, and iterative validation. This involves understanding the potential impact of any change, defining clear success criteria, and establishing contingency plans. The process should include stakeholder engagement to ensure alignment and transparency throughout the project lifecycle. Question 19. The investigation demonstrates that a third-party vendor, responsible for managing a critical security patch for the vCenter server appliance, has identified a zero-day vulnerability and is urging immediate deployment. The vendor claims that the standard change control process, which requires a minimum of 48 hours for review and approval, will expose the environment to unacceptable risk during this period. The IT team is under pressure to act swiftly. Option A. Inform the vendor that the organization cannot deviate from its established change control policies and instruct them to wait until the standard approval process is completed, regardless of the security implications. Option B. Initiate the standard change control process, documenting the vendor's urgency and the potential risks of delay, while simultaneously preparing for an expedited review and approval if deemed necessary by the Change Advisory Board. Option C. Escalate the situation to senior management, requesting an emergency change control exception that allows for a rapid, but still documented, review and deployment of the patch. Option D. Immediately deploy the patch as recommended by the vendor to mitigate the zero-day vulnerability, bypassing the standard change control procedures due to the critical nature of the threat. The correct answer is B. Initiate the standard change control process, documenting the vendor's urgency and the potential risks of delay, while simultaneously preparing for an expedited review and approval if deemed necessary by the Change Advisory Board. Explanation. The investigation demonstrates a common ethical dilemma in IT environments where a vendor, seeking to expedite a critical patch deployment, bypasses standard change control procedures. This scenario is professionally challenging because it pits the immediate need for security against established protocols designed to prevent unintended consequences and maintain system stability. The pressure to resolve a potential vulnerability quickly can lead to shortcuts that, while seemingly beneficial in the short term, carry significant risks. The correct approach, which involves adhering to established change control processes even under pressure, represents best professional practice because it upholds the principles of due diligence and risk management. VMware's best practices, as reflected in the 2V0-622 PSE exam objectives, emphasize structured deployment and rollback plans. Following change control ensures that the proposed modification is reviewed, tested where feasible, and approved by relevant stakeholders, minimizing the risk of service disruption or further security issues. This aligns with the professional responsibility to maintain the integrity and availability of the virtualized environment. An incorrect approach, such as immediately deploying the patch without proper review, constitutes a regulatory and ethical failure. It bypasses the established governance framework, which is designed to protect the organization from operational risks. This action could violate internal policies and potentially lead to a breach of service-level agreements, SLAs, if the patch causes unforeseen issues. Furthermore, it demonstrates a lack of professional accountability by circumventing established risk mitigation procedures. Another incorrect approach, which is to delay the patch indefinitely due to the perceived inconvenience of the change control process, is also professionally unacceptable. This inaction leaves the environment vulnerable to the identified security threat, which is a direct contravention of the IT professional's duty to protect organizational assets. It prioritizes procedural ease over critical security imperatives, creating a significant risk exposure. The professional decision-making process in such situations should involve a clear assessment of the risk versus the reward. While urgency is a factor, it should not override fundamental security and operational protocols. The professional should communicate the risks associated with bypassing change control to management, clearly outlining potential negative impacts. If an expedited process is absolutely necessary, it should be formally requested and documented, with a clear plan for post-deployment verification and rollback. This ensures transparency, accountability, and a structured approach to managing critical incidents. Question 20. Upon reviewing a proposal to integrate a new, proprietary storage virtualization solution into the existing VMware vSphere 6.5 environment to enhance performance and reduce latency, what is the most appropriate initial step to ensure a secure and stable deployment? Option A. Deploy the solution in a production environment and monitor for any issues that arise, addressing them as they occur. Option B. Conduct a comprehensive risk assessment to identify potential vulnerabilities, compatibility issues, and operational impacts, and document mitigation strategies. Option C. Focus solely on verifying the performance benchmarks provided by the vendor and ensure the solution meets the advertised latency reduction targets. Option D. Proceed with the integration immediately, as the vendor's documentation highlights significant performance improvements and claims robust security features. The correct answer is B. Conduct a comprehensive risk assessment to identify potential vulnerabilities, compatibility issues, and operational impacts, and document mitigation strategies. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization environments where the introduction of new technologies, even seemingly beneficial ones, carries inherent risks. The professional is tasked with evaluating these risks without the luxury of extensive historical data or established best practices for this specific, novel integration. The challenge lies in balancing the potential benefits of enhanced performance and efficiency against the unknown vulnerabilities and potential disruptions to critical services. A hasty decision based on incomplete information could lead to significant operational downtime, data loss, or security breaches, all of which have severe implications for business continuity and regulatory compliance. The absence of a predefined risk assessment framework for this particular integration adds another layer of complexity, requiring a proactive and structured approach to risk identification and mitigation. Correct approach analysis. The correct approach involves a systematic and documented risk assessment process. This begins with identifying potential threats and vulnerabilities associated with the new technology, such as compatibility issues with existing infrastructure, potential performance degradation under load, security loopholes, and the impact of failure on critical business applications. Following identification, each risk must be analyzed to determine its likelihood and potential impact. This analysis should then inform the development of mitigation strategies, which could include phased rollout, comprehensive testing in a non-production environment, contingency planning, and the establishment of monitoring mechanisms. Documenting this entire process, including the rationale for decisions and the identified risks and their mitigations, is crucial for auditability, knowledge transfer, and demonstrating due diligence. This aligns with general IT best practices and regulatory expectations for managing technological change and ensuring system integrity and security. Incorrect approach is analysis. Implementing the new technology without a formal risk assessment, relying solely on vendor assurances or anecdotal evidence, represents a significant regulatory and ethical failure. This approach bypasses the critical step of identifying and evaluating potential threats to data integrity, system availability, and security. It demonstrates a lack of due diligence and a disregard for the potential negative consequences, which could lead to breaches of data protection regulations or service-level agreements. Adopting a wait-and-see approach, where the technology is deployed and issues are addressed reactively, is also professionally unacceptable. This reactive stance exposes the organization to immediate and potentially severe risks without any proactive mitigation. It fails to meet the ethical obligation to protect organizational assets and data, and can lead to non-compliance with regulations that mandate proactive risk management and business continuity planning. Focusing solely on the potential performance benefits while neglecting security implications is another critical failure. Modern data center operations are subject to stringent security requirements. Ignoring security risks associated with new technology integration, even if it promises performance gains, can lead to vulnerabilities that compromise sensitive data and violate data privacy laws. This demonstrates a narrow and incomplete understanding of the holistic responsibilities of a virtualization professional. Professional reasoning. Professionals in data center virtualization must adopt a proactive and structured approach to risk management. This involves establishing a clear process for evaluating new technologies, which includes 1. Identification, systematically identifying all potential risks, both technical and operational. 2. Analysis, quantifying the likelihood and impact of each identified risk. 3. Evaluation, prioritizing risks based on their potential severity. 4. Treatment, developing and implementing appropriate mitigation strategies. 5. Monitoring, continuously reviewing and updating the risk assessment as the environment evolves. This framework ensures that decisions are informed, defensible, and aligned with the organization's security posture and regulatory obligations. It promotes a culture of continuous improvement and resilience within the data center environment.